So I always tell my students that when we're factoring or learning how to factor, I usually give them this list of steps for factoring trinomials. And that first step there, it's almost like a disclaimer. Make sure that that everything's in order. And what I mean there, that really applies to trinomials when you have an x squared plus an ax squared plus bx plus c. You see how that squared is, you're going from x squared to x to the first power, and then you don't have an x at all right here. Well, that's what I'm talking about, because every now and then it shows up as like bx plus c plus ax squared, and you have to rearrange it so that it looks like this. Anyway, that step, again, it's more of a disclaimer. If you have to spend more than about 5 seconds looking to see if the thing's in order, just skip that step, because if you spend more than 5 seconds looking at it, chances are it's in order. Okay. Anyway, we have step 1, make sure we're in order. So I'm moving on to step 2. Is there a GCF? Well, let's see. The x happens on both sides, right? So let's take out an x cubed, because x cubed happens in both places. And if I take out an x cubed, I'm left with y to the 4th minus 16. Now, the way that I'm left with this, I'm just dividing everything by x cubed, basically, because that was the GCF. So that stayed in the front, and now I'm looking at y to the 4th minus 16. So once step 2 is done, I have to determine, are we looking at a binomial, a trinomial, or a polynomial with 4 or more terms? Because if it has 4 terms, we're going to group it. If it's a binomial, there's 3 formulas, and if it's a trinomial, I'd use the rooftop method. Well, this is a binomial, so let's see what formula it fits. Okay, is it a difference of squares? Is it a difference of cubes, or is it a sum of cubes? Well, difference means minus, right? So it's going to have to be a subtraction problem, and it's going to be squared if it's a difference of squares. And if it's a difference of cubes, something's going to be cubed. You're going to have perfect cubes. And if it's a sum, well, that's going to mean plus, and cubes means, again, something's going to be cubed. Well, I don't see anything. 16 is not a perfect cube, so that rules out the 2 cube formulas. And we look at the difference of squares. 16 is a perfect square, but is y to the 4th a perfect square? It actually is, because y to the 4th is y squared squared. Okay, it's pretty interesting, huh? So it does fit the formula. We're going to leave the x cubed in front, and we're going to have a plus and a minus. And we're going to take the square root of y to the 4th, which we said was y squared, and we're going to put that in the front. And we're going to take the square root of the 16, which we already said was 4. And this is a special case. The x cubed, that GCF, was perfectly factored. We factored it out. Y squared plus 4 does not factor. But y squared minus 4, that's still 2 perfect squares, and they're subtracted. So we can draw that set of parentheses again and do the whole plus and minus thing again. And the square root of y squared is y. The square root of 4 is 2. And now it's fully factored.